touch like a pastry control or something, would it still work with the input?
Yeah, it would. It's actually really cool because we like attach Xbox controllers for some of our games. Yeah, and it actually works really well. So it depends on what. So there are various libraries you can download in your Unity file for that specific purpose. But yes, they are out there. Those libraries. No, not really. You don't really need to, but yeah. There are so many things you can download, like libraries and stuff like that, that will help you out so much.
What's the capitalization for
It's
capital R, capital B, right? And what's the import look like?
Or no, not B.
Oh, the B's not capitalized?
No.
Oh. Is that new? What?
Just kidding. B is not.
Yeah. I kind of screwed up and just started the webcast right now. Yeah. We're going to be putting it on the Facebook page. Yeah. Yeah, it's okay.
Awesome. Now try it. About where we're the scouts.
Daniel, should I continue? Some people are still.
Looks like people are still.
Yeah.
So give it like a minute more.
So for HUD team, we made it so there was like a playing field in AR space, like augmented reality space. So we had glasses that you wore, and there was like image projected on the glasses. And so like on this table, you would see a playing field with a bunch of trees running at a wizard. And to control the wizard, you would like do hand motions. Wait, where's the video? Oh, it's on Bill's website?
No.
Is it on Bill's
Okay, no, you're not going to show his picture to everyone. But don't.
But yeah, that whole thing was made in Unity. This thing right here. Yeah, it's kind of hard to see, sorry. Here, I'll skip to the good part. The stuff where, yeah. So all this was made in Unity by me and my team. Yeah. The wizard was actually made in Maya too. Yeah.
How are you capturing? Oh,
so cool.
We have a sensor, a depth sensor, on top of our glasses. Yeah. So if you notice, like right there, the yellow thing, that's holding our sensor. Yeah.
Does it only capture hand movement or like?
I think it's like 3 feet. 3 feet ahead. So like, if someone walks ahead, I doubt it'll pick it up. So, okay. So is everyone good for the most part? Slight interlude.
How long does that take?
If anyone wants
Semester.
a working checkpoint file, just let me know and I can airdrop them to you if you have a Mac or send it to you.
Yo, James. Yes. Okay, so when you run it, you might be wondering, wow, this is like really slow. I really want to make this go faster. Right? Weren't you thinking that? Right? Okay, so In our script, we have this force vector which applies the force, but to like make it go faster, we have to apply a larger force. And so what we can do is implement a force coefficient. So this is just some number that you can manually input that will make the force vector like, you know, higher. And so what you can do is declare a public float, and we can just call it speed. And so the cool thing about Unity is that whenever you declare a public variable, you can edit that on your, like, you know, Unity dashboard here, or whatever you call it. So it should be like right here in the script section, but you don't see it here right now. But no fear, it'll show up once you like run it and then unrun it once. Did I save it? Okay, there it is. So you see the speed right here. And so, like I said, all public variables you can edit like on your Unity dashboard. But we need to figure out how we're going to use it. So, like I said, this is like a force coefficient. And so we can just multiply this by our force vector. But it has to be like non-zero, or it has to be greater than 0, because if you multiply it by 0, then it's not going to move. So what we originally had was a speed of 1, because like it was just this force vector, but we can, like, you know, multiply the force vector by 2 by increasing this to 2, or like, you know, 4. So you guys can test out the different speeds. Yeah. See, it goes a bit faster. And then you can put it on steroids. You can do like 100 and then watch it like fly off the screen. Whoa. Yeah, that was pretty fast. See what it does for 1,000. I think it's gonna like disappear at 1,000. Just in one, like, yeah. Here's the script. So we added this public float and then put it down here, multiplied it by the force vector. Awesome. Okay, so now that we've like made the ball roll and make it roll at like a decent speed, we can like fix the angling of the camera, because if you notice when we run it, like the camera stays still when we move the ball, and that's pretty boring. So what we should do is we should make it so that, like, you know, the camera follows where the sphere goes. And an easy way to do this is to simply, or this is for most, you can do this with anything in Unity to make things like stay like in a group, is you can drag them and like put them on top of each other. And so essentially this keeps them the same, like in the same vector wise. So they'll stay the same. But if you run it, and you guys can see for yourselves, hold on. This doesn't go as planned. But what we can do is actually implement a script for our main camera. So just go to new script, and we can call this camera behavior. And so what we're trying to do is make it follow the sphere, right?
Wait, so you add a component into the camera?
Yeah. in the main camera. So we want to make the camera follow the sphere. And so that sort of means that you want to have that game object, the sphere game object, in your script so that you can, like, you know, mess around with the vectors. So what we're going to do is have a public game object, which is going to be our sphere, but we can just name it player since, like, you know, it's our game. We're going to be controlling the sphere. And then we want to have an offset. And it's okay if you don't understand what this means, but we want to make sure that the distance between the sphere and the camera stays the same during the whole game. And so it's going to be a vector, vector 3, and that's going to be our offset. And so what is our offset? Like I said, it's the distance between our camera and our sphere. So it's just going to be the transform dot position minus. So transform is like, you know, the camera, like where it is. So we're taking the position of the camera, and then we're subtracting it from the position of the sphere. And that's going to be our offset.
How does the program know that the sphere is the player?
Good question. I'll show you in 1 second. So
What did he ask?
he asked how we know what the player is, the sphere. And like I showed before, when you declare a public variable, it shows up here. And so what we can do is actually drag and drop the sphere into this right here. If it'll load. There. And so this is sort of like declaring the variable. I dragged the sphere object right here. I dragged it from here all the way into here. Player. From the camera component, script component.
Should everyone have a player on it?
You don't have to, but
Or like there's no name, it just has the.
so if it's not showing up, just like run it and then unrun it, and it should show up. Do that like a couple times. So is everyone able to do that? It's like declaring a variable in real time and not like on a script.
Why after I put sphere to the camera, like now when I click main camera, it goes to the sphere?
Do you have the sphere under main camera?
I do, like, but now I can't drag the main camera.
What do you mean you can't drag it?
Like when I click on main camera, it goes to the sphere.
When you click on this?
Yeah. I can't move the camera in.
So like
Wait, I think I just move the sphere out.
what?
Yeah, I was like, what happened was when you click main camera, it would click the sphere instead.
It
Yeah,
would?
Yeah, like right there.
The camera
Yeah.
is like
Okay, yeah. So that's because sphere is under the wing of main camera.
Oh, okay.
Yeah.
Right now, then how do I fix the viewpoint?
So take sphere under from this, and then you can do that.
Oh, okay.
Yeah.
I see.
What happens if you connect your camera to several objects and all the objects are moving at the same time?
So everything under the wing of an object moves with that object. Does that make sense? So like, if you had your sphere under the plane, not under directional light, under the plane, then nothing would happen. But let's say you had the plane under the sphere. It would move with it. Does that make sense? Okay, so now that we've made the player the sphere, we can use our offset to our advantage to make it so that the camera stays with the sphere. And so what we can do is in update, we can have it so that the position of our camera, transform.position, is equal to the position of our sphere plus our offset. And again, the offset is the distance between our sphere and our camera. And so when you run it, you can see that the camera follows the sphere. This is the script again, in case you guys didn't catch it.
Is it supposed to be like faster? It feels faster.
I mean, considering this is like the first time seeing Unity, this is a pretty good pace. I mean,
No, I'm talking about like the ball. Like when I lost the camera to the ball. Like it seems like it's rolling faster.
it's rolling faster. Can I see?
Yeah. So speed's only 4.
Speed's 4. Oh, your sphere shouldn't be under the wing of camera. I was just showing that as like what you would assume you would do.
Oh, okay.
Like based off of like attacking the problem of getting the camera to follow the sphere.
Oh, okay. So,
So-
like, what happens when sphere is under?
So I was showing her this too. So if you have like sphere under the wing of plane, you can see that like nothing happens. Like you would think that like plane would move with sphere, but it's actually the other way around. So if you put plane following where the sphere goes, hold on, if I can drag and drop, there, then you can see that, wait, what? Okay, it has to do with, but if I didn't have this offset like this, then it would show like the sphere attached to the plane falling. But since we have this script running,
Oh, okay.
it's gonna stay where the camera is. Yeah.
So like you wouldn't put it, like basically like.
Yeah, so I'll just comment that out to show you. So if you put plane under, then it'll just fall.
Oh. Okay.
So the plane follows where the sphere goes.
Okay.
Yeah. Yeah, sorry.
I think my sphere now is moving weirdly, like when I'm trying, when I click left, and then it just keep on going.
So sphere should not be under the wing of main camera. Like, you know how we drag and drag sphere?
We're not supposed to.
No, it shouldn't be there. I was just showing that to show that like that's what you would think to do, but that's not actually what you do. Sorry.
So what happens when you do that?
So, like for example, if you dragged plane and dropped it on sphere, that would make it so that the plane follows where the sphere goes. Right?
Right. Why don't we want the camera to follow the sphere?
Because the camera would like rotate like the ball rotating. Like it would go, you know, yeah.
I see, thank you.
Yeah, no problem. Yeah. Okay, so are we all good with the script? Awesome. So we have this so far, but we don't want to fall off, right? Because like that would make the game a bad experience. So what you guys should do is you should implement new 3D objects to create a barrier, and I'll let you guys try that on your own. But just a reminder, you can go to create up here, 3D object, and pick cube, and then rescale that to make like a barrier.
What? Where's the green line that we made? No, we didn't use it.
So you can do double How do you control it so it doesn't just go up and down?
What go up and down?
You know how like I try to move it like to the side, but it's kind of hard because like.
Are you using the arrows? Click on the arrows.
We just move the camera view instead.
Oh no, you have to like physically click on those arrows. Yeah. And you can't use yeah like that. Okay, is everyone good? Did you make your barriers so that you don't fall off?
How do you like set it to like just when I said in and out to like choose
So you have to like click on these. You see these like 3 arrows.
yeah.
You use that to move it around.
How do you delete an object?
Right click and yeah, delete.
How if we move the camera to like the opposite way that we want? So the view that we looked at left is when we click left is going right. When we click right is going left. We just somehow altered the camera to like the opposite direction.
Wait, sorry, what?
Like
What?
I switched, like somehow rotated the camera, so when I my view of left.
Just fix the rotation manually. Just click on it, and then up here, you can just change it to like 0, 0, 0.
Use this arrow. The top one.
Yeah.
I just made it like bigger. I like resized it.
That's like you would use this to make it smaller.
Yeah. Whatever. Yeah, that's the good part. Yes. Yes. Okay, so did everyone make their barriers? No?
How do I like get my camera to always it's like
To- always what?
how do I get my camera to point at the wall? It's like hard to
Like, you want to change the like angle of viewing?
yeah.
Well, you can change the rotation just manually, or you can like physically move it like this. Yeah.
Wait, what? How is that possible?
I can't see it.
But it's still like. How do you get the camera to like angle like that?
I just set it to a 45 rotation, 45 0 0.
Your camera's like all. Just move like forward, like closer to you. Yeah. So kind of easy. I'm gonna have to head
So
out soon.
we only have like 2 more things to do. We're gonna be adding the like pickup objects like of the game, and then implementing the UI.
Okay.
The UI, they're both not that like big.
Okay.
Like,
They're all gonna be webcasted, right?
yeah.
Okay.
Let me double check to make sure it's webcasting. Yeah. Yeah.
Alright.